Welcome back to WAPSI. So we can start a new section. Okay. The first question. The first question is the difference between equivalent capacitance of two identical capacitors. Two identical capacitors connected in parallel to that in series is 6 microfarad. Okay. So the capacitance connected in parallel and capacitance connected in series. Okay. The difference between two equivalent capacitance of two identical capacitors connected in parallel to that in series. That means Cp minus Cs. Capacitor in parallel minus capacitor in series, which gives 6 microfarad. Okay. The value of capacitance of each capacitor is. So, when two capacitors connected in series and parallel, what will happen? Okay, it has a resemblance with the resistor, but it is far away from the resistors. When the resistors connected in series, it is adding. Okay, when the resistors connected in parallel, we are actually taking the reciprocal. Okay, similarities are there, but when the capacitor are connected in series, actually we are taking the reciprocal. So 1 by capacitor series will equal to 1 by C1 plus 1 by C2. When they are connected in series, actually we are taking the inverse combination. Okay, and C1 and C2 are equal, so we can write this as 2 by C. 1 by C plus 1 by C is equal to 2 by C. So Cs is equal to 2 by C. Okay. Cs is equal to C by 2. C by 2. Put that in a box. Next, we want to calculate the Cp. When the capacitors are connected in parallel, we are just adding the values. Okay. So Cp is equal to C1 plus C2. And C1 and C2 are equal, that is C. So Cp is equal to 2C. So 2C minus C by 2 is equal to 6 microfarad. Okay, so 4C by 2 minus C by 2 is equal to 6 microfarad, which is equal to 3C by 2 is equal to 6 microfarad. Okay, so C is equal to 6 into 2 is 12, 12 by 3 is 4 microfarad. Okay. Capacitance of capacitor is 4 microfarad. Okay, we can check with our option. Option C is the correct answer, 4 microfarad. Okay, so we can move to the next section. Next question. Next question is the second one. A metal rod of length 10 centimeter. Okay. Length 10 centimeter. Okay. And a rectangular cross section of 1 centimeter into 0.5 centimeters. That means we can draw a rectangular cross section on the both sides. Consider that this is our metal rod. Okay, 10 centimeter of length and 1 centimeter of in here, 1 centimeter and 0.5 centimeter on here. Okay. The resistance will be, okay, when does the resistance will be maximum? Option A is maximum when the battery is connected across 1 centimeter into 0.5 centimeter phases. That means they are connected across these two phases. The option B is maximum when the battery is connected across 10 into 0.5. 10 into 0.5 is here and this. Okay, see, we can see that when the resistance, when does the resistance get increased? Actually the length between that connection is just increasing. Okay, when the length increases, length of the rod increases, the resistance get increased because R is equal to rho L by A. Rho is the resistivity and it is directly proportional to, and the resistance is directly proportional to length. Okay, in which phase we have to connect 1 centimeter into 0.5 centimeter phases, because this has a maximum length of 10 centimeter. Okay, a 10 centimeter length between these two phases. Okay, so this is the correct answer. That means 1 centimeter into 0.5 centimeter phases. Option A is the correct answer. So we can move to the third question. A car has a fresh storage battery of EMF 12 volt and internal resistance 2 into 10 raised to minus 2 ohm. Okay, very negligible internal resistance. Okay, if the starter motor draws a current of 80 ampere, okay, then the terminal voltage when the starter is on. Okay, actually this internal resistance will draw a current. Okay, will draw a voltage. Okay, so the current is 80 ampere. So the effective voltage V will be EMF minus I into internal resistance R. EMF is 12 minus I is 80. 80 is multiplied by 2 into 10 raised to minus 2. 2 into 80 is 160. 160 into 10 raised to minus 2 is 1.6. So 12 minus 1.6 is equal to 10.4. So option C is the correct answer. 10.4 volt. Okay. Then we can move to the fourth question. A potentiometer has a uniform wire of length 5 meter. Okay, uniform wire of length 5 meter. A battery of EMF 10 volt and a negligible internal resistance is connected between its end. Okay. A secondary cell connected to the circuit gives balancing length. Okay, a secondary cell, another cell is connected across it, across a length. Okay, across a length only. A secondary cell connected to the circuit gives balancing length at a 200 centimeter. The EM of the secondary cell. So 200 centimeter means what? 2 meter. Actually, the total length of the wire is what? 5 meter. So out of 5 meter, they are taking actually 2 meter. So 2 by 5 is just multiplied by 10 volt, which is equal to 4 volt. Okay, so 4 volt is the EMF of that battery, and option A is the correct answer. See, then we can move to next question, the color code. Okay, so I will say the sayings. B.B. Roy, Great Britain, very good wife. Okay, black, brown, red, orange, yellow, green, blue, violet, gray, white. Okay, and they are giving 0.28 kilo. What is 0.28 kilo? 1 kilo means 10 raised to 3. 0.28 into 10 raised to 3 is nothing but 280. That means 28 into 10. So the power is 1. So the first one will be 0, 1, 2. First one will be red. Okay, all option has first one as red. Okay, and the second will be 8, 0, 3, 4, 5, 6, 7, 8. Gray. Second color will be gray, and they are saying that option A and option C has gray. So option B is wrong. Option D is wrong. And 10 raised to 1 is brown. So from comparing the option A and option C, the brown one is the option A. So the option A is the correct and option C is wrong, because they are marked as silver in the third place. Third place gives the power of the 10. In here the power is 1 and 1 is brown. Okay, then option A is the correct answer. Okay, then we can move to the sixth question. See, this sixth question is very, very important. Okay, so in here we are actually applying Kirchhoff laws. Okay, each resistance in the given cubical network has resistance of 1 ohm. That means identical resistors are connected in here, 1 ohm, and equivalent resistance between A and B. Okay, we have to find the equivalent resistance is. Okay, they are asking the equivalent resistance between A and B. Actually, I am going to redraw this figure. Nothing but a symbol A simple adaptation is done to this figure. Okay, this is A and this is B. See, actually I am connecting a battery to this between these 2 points, and I am saying that the current actually produced is 3I ampere. Okay, 3I is the total current produced in here. I am saying that I don't know what is I. Let's imagine 3I is the current. Okay, see, actually the circuit is identical by means that it is divided into 2 parts, and each part is connected to another 2 divisions. See, another 2 divisions, another 2 division. Okay, and each are coming back. So we can say that each branch are dividing the current equally. Okay, so I through here, I through here, I through here, because all branches are equally connected, equal connection. That means each resistor have 1 ohm of resistance. So each branch have equal current drop. So I am actually writing that I through here and I through here and I through here. So after this connection, the current is at here, and the current has to be divided into 2 parts. In this part it will be I by 2, and in this part it will be I by 2, because in here it is connected into 2 parts and in here it is connected into 2 parts. That means identical in nature. Okay, so but the current coming from this also coming from here, so the current only wants to go to here. Okay, so the current from here it will be I by 2, and the current coming from this is I by 2. So the total current coming from here is I. So I marked the current at here as I by 2. Okay, then please observe that this is another one way, and this is one way which is parallel to here, so the voltage is same, and this is parallel to here, which is the voltage is same, and this is parallel to the first this connection, that means the voltage is same, and this is another way which the voltage is same, and this is the one way which is voltage is same. So we only need to calculate the voltage through this line. Okay, so I am calculating that, let V be the voltage. So V is equal to I into R plus I by 2 into R plus I into I by 2 plus I by 2 is total, we get an I in here. So I into R is the total voltage drop crossing this resistance. So V is equal to 2 IR plus IR by 2, which is V is equal to 5 IR by 2. Okay, V is equal to 5 IR by 2, and I can say that the effective voltage V is equal to IR, but what is the current in here? 3I. Okay, the current in here is 3I, and the resistance, effective resistance is R effective. Okay, so 3I R effective should equal to 3I R effective should equal to 5 IR by 2, 5 IR by 2. So I can cancel these I's, and R effective is equal to 5R by 2 into 3 is 6. So 5R by 6, and we know that R is 1 ohm. So R effective is equal to 5 by 6 ohm. So what's 5 by 6 ohm is the option A is the correct answer. Okay, in here I applied the Kcet voltage rule. Okay, that means the total voltage will be dissipated according to its potential, according to its resistance and current, and we get the same voltage in parallel connection and equal current in series. Okay. Yes. So we can move to the seventh question. Seventh question is IV characteristics of a copper wire of length L and area of cross section A is shown in the figure. The slope of the curve become, okay, the change in slope is actually they are focusing on the change in slope. You don't know what is slope. We have to derive what is slope in this graph. Okay. Options are more, that means increasing. If we perform in high temperature, that means when we increase the temperature it will increase. Okay. Option B, more if a wire of steel of same dimension is used. A wire of material, they are focused, option B is focused on the type of material, and option C is less if the area of the wire is increased. Okay, that means okay, the area of the wire is increased, that means the slope is getting increased. Okay, less if the length of the wire is increased. Okay, actually we have to find what is the slope of this graph. Okay, what is slope? Slope is defined as change in y by change in x. Okay, dy by dx, change in y by change in x. So in the y axis it is current, so slope is equal to I by V, and V is equal to IR, so I by IR, which is equal to 1 by R. So actually slope is nothing but inverse of resistance. Okay, when resistance get increased, the slope get decreased, and the first option is more if the experiment is performed in high temperature and it is copper wire, perfectly conductor, not a semiconductor. So when temperature increases, the resistance will increase. So when the resistance will increase, slope become decrease, and the option A is wrong. That means if because if the temperature get increased, the slope get decrease. Okay, and it is not more, it is less. So option A is incorrect. And option B, more if a wire of steel of same dimension is used. Okay, option B is make not any sense. Option C is less if the area of the wire is increased. When the area of the wire is increased, the resistance get decreased, because R is equal to rho L by A. When area increase, resistance decrease. When resistance decrease, slope will increase. That means when area increase, slope will increase. Okay, so less if the area, that also incorrect. Less if the length of the wire is increased. When the length of the wire is increased, the resistance will increase. When resistance will increase, the conductance will decrease. That means the slope get decreased. So less if the length of the wire is increased. That means the slope will decrease when L is increased. When L is increased, R get increased. When R get increased, the L get the slope get decreased. So option D is the correct answer. So option D is the correct answer. So we can move to the 8th question. Okay, a 220 volt AC supply is connected between a point A and B as shown in the figure. So we have to find the potential difference between the capacitor. Okay, see, if we removed a capacitor, there is only a diode. Okay, diode will rectify the AC source, but it will not affect the potential. Potential will remain the same if we connect a diode in the circuit. Okay, that means 220 volt will be here, but the capacitor, what does the capacitor is doing? In the capacitor, the AC source, it will act as a conductor. Okay, so some voltage is actually dropping by the capacitor, and the effective drop by the capacitor is 220 times the root 2, because we want to calculate the RMS value. So the RMS value is derived from the 220 multiplied by the root 2. So 220 is multiplied by root 2. Option D is the correct answer, because it is the concept related to the RMS value. Okay, students will check how the root 2 is arrived. Root means square of AC circuit. That is very very important because it is related to voltage, it is related to current, okay, and it is related to power because P is equal to VI. All the terms with related to voltage and current, the RMS value is related, okay. So we want to check that whole thing. And the ninth question is, okay, in the following circuit, what are P and Q? What is the result of P and Q? Okay, so actually in here this is 1 and we don't know the Q, okay, then we, and also we don't know the P, and the unknown quantity has given us the input in here, okay. Actually we know that this is 0 and this is 1. If this can be 0 or 1, okay, anything 0 or 1, okay, only two chances, 0 and 1. If it is 0, this will 0, okay. If it is 1, this will 1. So there is two chances, 1 or 0 to be the output, okay. And if this is 0, and this can be also 0 or 1, and the answer, what's the answer? But the answer from this is only 0 because the first quantity is 0 and 0 is productive with the 0, the answer is 0, 0 is productive with the 1, the answer is 0. But a NOT gate, a NOT is given, so opposite to the 0 is 1, so the answer for the Q is always 1. So Q is 1, two options are there with the Q is equal to 1 and we want to check the P. When Q is equal to 1, we can give this as 1, 1 into 1 is 1, complement of 1 is 0. So only one and only answer for the P is 0. So P is 0 and Q is 1. Option B is the correct and option D is the wrong answer.